Okay, we're here for the certificate session. No, I will not cover cryptography and everything about certificates in 75 minutes. Yes, you will not walk out of here knowing how to configure your one service to use SSL, because just doing Apache, just doing Wi-Fi 802.1x, it takes a long time to do this stuff. What I want to get out of the session is for you to not be frustrated like I was about a year ago. And I spent a lot of time trying to troubleshoot information with customers. Let me see. When I talk about myself, I'm Tim Perfitt. I was a founder of TwoFactor Software, ex-Apple, 11 years at Apple, returned Peace Corps volunteer, NT 4.0 administrator, Windows 2000 desktop administrator, all that good stuff, right? And one of the things I was doing about a year ago is helping people integrate iPads and iOS devices and Macs into infrastructures that were large. And when you talk about large infrastructures, you're starting to talk SSL and certificate-based, PKI, large-scale environments. I didn't have access to the environments. The people I was talking to did not have access to the environments. All they knew is it didn't work, right? They have their iOS device. They try to hook it up to Exchange with SSL. They try to hook it up to the wireless network. And it uses 802.1x, or it uses certificates for authentication, and it just wasn't working. So I'd get on the phone with them, and it would be the initial discussion like, don't worry, it does work. We can get this to work, but we need some more information. And the more questions I asked, I realized that wasn't the person that could answer this question. And then we bring more people on, and 3 weeks later, we had like 12 people on the phone call, and I still couldn't actually get the certificate chain, right? Because none of them had access to the device that was giving it. That iOS device couldn't pull down the chain and show it to anybody. So there's nothing to look at. So we just basically close your eyes and try different checkboxes, right? How does that usually work out for people when they just check a bunch of boxes and see if it works? Sometimes you're really lucky, right? People think you're this super genius. Like, oh, look, I checked this box and it all works now. SSL doesn't work that way, unless you're really, really super lucky. You need to be able to get access to the tools to be able to do this. So what I want you to do when you leave this session is be able to, before you start troubleshooting an SSL problem, right? Because when you configure SSL for any service for the first time, it's not going to work, right? Because there's too many moving parts. Unless it's something you've done and documented, right? If it's any kind of new environment, it's going to take some understanding how it works as well as troubleshooting it. And God help you if you have to troubleshoot somebody else's environment. Because you need to have the information up front. And if they can't give that information to you, you need to tell them what you need. And you can't go any further until you get that information. So that's what I want you to do. So when you leave here, you won't know how to configure 802.1x, but you know that when you go and you select that pull-down menu and you start getting error messages, where to go next. Because once you know what to look for, it becomes a lot easier. And what people think their environments are, aren't. Right? People's web servers give you wrong certificates all the time. Right? People set up MDM, they'll give you a certificate chain that has nothing to do with what the service that they're doing. And they think they do because that's the checkbox they check, but they have no way to check it. And you can come in and say, this is the chain that you're giving me. And they're like, oh, so that 3 weeks we just spent troubleshooting this problem, it was because of this chain we could have done in 1 minute if we had just told it to you? The answer is yes. And you say it in a nicer way because they still have to give you money or buy product from you, but ultimately you got to have those tools to be able to do it. So that's basically... Certificates are everywhere now. If you ever looked into MDM or how Apple's push notification works, it's a good illustrative example of why people are using certificates and kind of the power of what they do. So when you send a push notification on your MDM service, from the user's perspective, right, you want to make a change on your iOS device, right, and you want it to do it, and it looks like what happens, the MDM server pushes down a profile, right? I want to have my passcode lock different. So my MDM server pushes down a profile. That's what the user thinks happened. That's not what happens at all, right? What happens is the MDM server has to send a push notification to Apple's server, their server infrastructure. It has to authenticate. And the user doesn't put a username and password in a web form. What happens is it uses client-based SSL certificates to authenticate to the push notification server. At that point, the push notification server contacts the iOS device. iOS device has a certificate when you first provision it, right? That's when when you first turn on your iPad or iPhone and you put in the information, it says contacting Apple or whatever. It actually provisions an identity on that device. So it can mutually authenticate itself to the server, and the server is using SSL as well. So there's a mutual authentication process that happens. So you make sure that it's it. And at that point, the MDM server says to your device, you need to talk to your MDM server. And at that point, the iOS device connects up to the MDM server, and will either, that's up to the individual person at that point, but most likely it's an SSL connection, either one or two-way authenticated. And the user does nothing, right? There's no password. The administrator doesn't put a password. It all happens automatically. But think of how secure that has to be, right? If you can inject anything into that process, you can basically take over the device. So SSL is an intricate part of that, and it looks easy, but it's difficult to get all the moving pieces right. So Apple's push notification is like a great example of something that looks seamless one-way connection when it's actually there's a huge number of moving parts. And you can also inject like Urban Airship and that kind of stuff to make it even more complicated. Because who doesn't love more complicated? Your bank. So this is, I love this. I asked this question in my office, and I was amazed at the response because I work with a bunch of technical people. And I asked them, if you want to go check your balance at the bank at Starbucks, right? And you go and you open up a browser. And is that safe? Right? Should you do that? Right? And the response was, should we do that here? Should we do this here or not? Let's do it here. This is awesome. Is it safe? Can people eavesdrop on your conversation? And should you check your balance at, and I'll throw in out Chase, right? You go and you open up your MacBook Air and you want to check your balance at Chase. Should you do that on Starbucks Network? Yes. Raise your hand for yes. Raise your hand for no. All right, so if you got to have the lock, right? If you have the lock and you trust the world government, and by the world government I mean VeriSign and all the certificate authorities, right? If you trust that, then you are connected. You're just as secure there, almost as secure there. You're just as secure there as you are at home, right? Because you have that SSL connection to your server. No? Fire sheet?
Yeah.
Oh, the first thing that allows you is for the social networks that you can take your credentials over and use it, right? But that's if you have an SSL connection where you trust it, that shouldn't be involved in that. All right. But the important thing to know is the SSL connection is what makes the client trust the server for this. So the bank is, SSL is what is used to be able to use untrusted, be able to communicate securely over untrusted environments. Exchange, anything else, services. There's a Exchange I bring out because you can use SSL or not use SSL. You can have IMAP, you can SMTP. Any of the services has an SSL option you can do over it. A lot of these places you can do client-based authentication too, so you don't even have to enter in a password. And we'll talk a little bit about two-factor authentication where you can do multiple things to make it even that much more secure. So why it rocks? It's very secure, combined with or compared to other similar systems. You're not using passwords. And one of the big pieces to this is that having users come up with secure passwords and not just use variants, the amount of entropy that's involved in a password decreases over time because the users reuse all their different passwords. The harder you get, the more password security you force on people, like the longer the passwords, that kind of stuff, the more likely they'll reuse the stuff they're doing before. So it's a cat and mouse game that we're losing. And so passwords, and it's just having, I had a nightmare situation a week ago where setting up my mother-in-law's iPad, I needed her iTunes account, and I said, what's your password? And don't ever ask that question to your mother-in-law, right? Because they have to go upstairs and they get the little piece of paper with all the passwords written on it that's crossed out, and they're not sure what their password is. It's manage your password. And I make fun of my mother-in-law. I had the same problem. My system's a little bit better. My piece of paper is in my keychain, but it's still a mess. If you have using certificates where you're authenticating the device, means that you don't have to remember all these passwords to be able to do it. And you can combine it with passwords to make it that much more secure. So the whole thing is that with two-factor authentication, it's something you have and something you know. Right? So somebody on the internet can figure out what you know. Right? They can steal stuff on your hard drive. They can do that kind of stuff. But if it's something you have, they have to come hit you over the head. And if they come hit you over the head, most likely they can't ask you what you know. Right? So you have to have both of those pieces of information to do it. And so that's why two-factor authentication works really well. Apple's combined that in iOS devices where one factor is the passcode on your device, and the second factor would be the SSL connection. And for a user, that's really easy. They just slide it open, they have that one 4-digit code, or maybe it's a complex passcode, and at that point then the services can connect with over SSL with client-based certificate, whatever way you set it up. And so you can authenticate the device, not necessarily just the individual person, right? So you got to provision these devices ahead of time. So it gets more secure, but the usability is still very high in it. And that's one of the reasons Apple likes to use SSL certificates to authenticate things, is because you don't have to have that interface popping up all the time to put your password in. All right, so any questions on that so far? Is that clear? It'll get more technical. I'll open the command line in a minute, but I don't want to get too deep too fast. This drives me crazy. People think that the reason it's not working is because they don't have the certificate. That there's like this magic certificate, you can just drag into your keychain and everything starts working. Like the certificate is their password, right? Like people think, okay, the server gives me a certificate, and if I have that certificate installed, we're good, right? Like it compares the two certificates. And that's kind of the simple way to look at it, and it is from a high-level view what happens, right? You got to have these certificates installed, and it works. But the problem is it lends itself to this shotgun troubleshooting. Is you just start grabbing certificates and installing them until it works, right? Which is sometimes works, not very helpful. So it's not how it works. You don't just take a server certificate and put it in your keychain, and the machine checks the two certificates to make sure they're the same and lets you in. That's not how certificate-based authentication works. This is another one. Like, oh, we have certificate chains, so I can't just install the certificate chain or just the server certificate. I have to have this thing called an intermediate and a root. So I just install those and everything works. So what they think from a high-level view is the server gives you a certificate, you check it, and then you check to make sure you have the certificate chain, and that's how it authenticates. That doesn't work either because anybody could hand you that certificate, right? How do you know you're actually connecting up to that server? So from a high-level view, people think that's work. But again, this lends the person to, oh, I just have to install this one and trust it. They have to install 3 and it works. But that's not how it works either, and that it's from a very simple view, sometimes this will work, but that's not how the trusted relationship works between the two. So the question is, what is it? If it's not just installing a bunch of password or a bunch of certificates that act like passwords, then we have to digress, and we have to talk about symmetric keys. Symmetric keys is the way the cool kids refer to password authentication, right? Challenge response. I have a password. I know what that is. The server has a password or a hash version of it, but we both share that same piece of information, and we can authenticate that way. So we don't want to send the password. That's how the old school system works, right? I have a password, and I just send the password over the network, right? People have found that that's a bad thing to do because some people have a copy of Wireshark, like myself, and could just look and see what the password is. So the way the symmetric works is the server comes out, and this is very simplified for illustrative purposes, but the server comes up with a challenge, A, B, C, D, E, F, G, sends it to you. You encrypt the challenge with your password, and you send that encrypted back with what you encrypted, and it checks it because it knows your password and it can encrypt it. There's some other hashing that goes on, but effectively that's what CRAM does to make sure that you both have the same password. The server knows your password, and you have the password. That sounds great, right? Because that works really well. If you share the same password, why can't we just all go off and be happy? There's a couple problems. You got to set up ahead of time, right? That server you have to know ahead of time. You have to provision the account to be able to do it. And password changes suck, right? Because if you don't want to keep the same passwords all the time. You want to change those on a regular basis. And so to be able to keep that in sync, it takes a lot of work and a lot of infrastructure. In fact, it's the main driver for a lot of help desks. It's just password changes. So that's where the whole idea of cryptography and using public-private key encryption came about. So the idea is this: at a very simple level, is you have 2 keys. You have a public key and you have a private key. And the public key you can share out to the public. You can tell anybody about it. And the private key you keep private to yourself. You never tell anybody about that. So that's like when an iOS device provisions itself, it will actually generate a private key, send up a certificate request up to Apple, and they'll issue a certificate down to them. So basically, it generates a private key and a public key, shares the public key with Apple. Apple signs a certificate that has that public key, and then it pushes it back down. So does Apple know what your private key is on your device? No, they don't know at all. And when does Apple know that private information? Never, right? So they never can. So that's why it was funny for me when you talk about, oh, well, the government will come in with their computers and with a subpoena, and they'll force them to use the back door, right? So there's cryptography involved. If they don't have access to the private key and they're using public key cryptography, it doesn't really matter if you understand the technology. You still can't break it, right? You still have to do a brute force iteration over all the different possibilities. So the idea is you can never have the information, they can't give it up. So it's one of those things that's like, if you don't tell me, I can't testify in court that I knew that, right? So just don't tell me what that information is. So I'm simplifying this a lot, but in order to get to the troubleshooting where you don't have to learn cryptography to do this, just know that asymmetric means you generate a public key and a private key, and you go ahead and share with the rest of the world all this public key stuff. So now let's go back to what do we think this is? So does the server send a piece of information? Do you start on your side, you take the public key from the server, and you encrypt a piece of information, and you send it down to the server, and the server verifies it. So the thing to realize about public key and private key is that you can't use a symmetric key. You can take a piece of information and use the same key to encrypt it and decrypt it, right? So it's a two-way system. I take my password, which is something 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 exclamation point, and I encrypt a piece of data, and I give it to Mike here. He uses that same password to decrypt it. With public key and private key, I take I take Mike's public key, and I encrypt something. I can't get access to the information anymore with the public key, right? I've effectively, unless I have the private key, I can't decrypt it. So that's kind of, for me, a fascinating thing. I could take this piece of information. I have this great photograph of a dog on a skateboard, right? And I don't want anybody to see that except me and Mike. I encrypt it with Mike's public key. Then I throw away the original. And I go back to look at it. I have no way to go back to the original because I've encrypted with only something Mike can decrypt. So I encrypt the dog on the skateboard, and I send it back down to him, and doesn't get it. So is this how it works? Are we there yet? No, we're still not there yet. We have another piece of information. One of the problems with using public keys and private keys is that, generally speaking, symmetric keys, you can encrypt large amounts of data. And everyone knows that if you have a dog on the skateboard, the resolution is going to be huge, right? You're not going to have a little small piece of data. And when you're encrypting things with public keys and private keys, you can only do little bits of data. So what I do is I come up with a symmetric key, right? I think of a good password that will be used just for a short period of time. I encrypt that with my public key, and I send it on down to the server, right? And then the server will have that symmetric key, and now we can do it just like we did password authentication. There's a lot more stuff that goes on in C, but ultimately that's what you're trying to do. Public key cryptography means that you're trying to switch over to symmetric keys as fast as possible, and they just use this information to be able to share this symmetric key. All right, so that's as much as we're getting into cryptography. It was a simplified version of it, so we know enough about that we have to have a public key, share it out to the people that are using our service, and we have to hold the private key hostage, not let anybody have access to it. And there's this certificate piece of information. So we'll get into now a little bit about certificates and the certificate chain, but the certificate that's issued has a bunch of other information that can be checked by the person consuming the service. Right? So you can look and see, is it the right version of the certificate? Does it have the dates are valid? Is the host name associated with it valid? So you can do a lot of verification of the certificate. And so we'll talk about this later, but this is where you get into the real mess of being able to troubleshoot these systems, because not only can you have invalid chains, and you can have things that the keys are incorrect, but also you can validate that it's actually supposed to be used for this activity, as well as the date's valid, is the host name valid, and can it actually be used for this purpose. So this is what the certificate chain looks like in keychain access on OS 10. You can see that a lot of the information, this is my, what is this one? This is my, so I was issued it by my own CA, which is not part of the world government. It's not in your trusted keychain. I just issued myself for my web server, right? And so I have some information associated with it. The big piece to look at is that is it still valid in the dates and the host names matches, and we'll look at that in a second. So here's some real life examples. So here's 3 of my services, and this gets in the first tool that to be able to troubleshoot a lot of these services, and hopefully my network connection will work. Let me go ahead and open up Terminal. And so OpenSSL is installed on every Mac OS X system. We actually connect up to our, let me make this bigger. Let's see. Actually connect up to our web server. Okay, and so what this does is so a lot of people associate SSL and certificates with web servers, right? But any port can have SSL running on it. In fact, ports that don't have SSL running on it, you can do a thing called what's called start TLS if it supports switching over to it. And so S-Client will allow you to connect up to any port. I'm using the standard 443 to do it, and actually see what the information is that are going with it. So the first step of troubleshooting is SSL even on. So if you can't connect with this and you get nothing back and you get an error message, it's not talking SSL on it at all. So the OpenSSL S-Client is a great way to connect up to it. First thing it does is it gives you the certificate chain that the server sends down. Because the server is going to send you down, most likely it's configured to send the entire chain. The root certificate, any intermediates, and the server certificate. So then you get these, and it's set by default to actually show you what the server certificate is. And so now you know that it has this chain that comes down. You can start probing it a little bit. But the first step is to know that you can actually connect up to it. And so for me, it gives a lot more information about the session ID and master key and all that stuff. The things that I look at is this, the certificate chain that comes down, and also the certificate from the server certificate. And a couple of really cool things that I almost always do is I copy the certificate and go into text edit, paste in the certificate, make plain text so it's nice, and save it to the desktop because desktop is the ultimate place to save things. And so there's 2 separate formats for certificates. One's PEM and the other one is DER. And they're the same, except one's text encoded and the other one's binary encoded. So this is text, so I'll make it PEM. And then if I go into if I do Spotlight, Spotlight has a Quick Look, it has a plug-in to actually look at a certificate. And if I double-click on it, it puts it in the keychain, but it doesn't really highlight where I went to, so it kind of gets lost. So I like to do Quick Look on it to be able to see it. So I'm actually looking at this. This is our actual SSL certificate from the server to look at. So that's a great way to know if it's running and to get the server certificate on it. So you don't have to, one of the troubleshooting steps is when you ask somebody to give you the server certificate, they might not know what it is. They'll get it from the network guy as the standard one, and it won't be the one that you're actually having trouble connecting up to. So the best thing to do is have the person you're troubleshooting with or yourself do this command and grab the certificate. You can do it through a browser, but that only works for stuff that works over 443. If this is like Exchange or if it's IMAP S or SMTP or something like that, you can just use SConnect and always get access to it. It's very easy. So that they have server certificate, and the S client you can use for connecting up to any SSL-enabled port. Actually, I could have just copied this. And here's our web server that we did, or our SMTP server. You can see I connect up to port 465. It's the issuing authority is GeoTrust, and it has a server certificate the same way. The third example I want to give was Apple's push notification. And there we go. Oh. There. So you can see this one didn't work. So we had a breakdown in communication. So you can see that it goes and it tries to get the handshake. And the push notification server requires a client-based certificate. So this one gets to the point of saying, yes, I actually have an issuing authority, but no, I'm not going to continue on because you have to authenticate with me before I continue to talk with you. So the illustrated point is here is just using this one command to be able to see if you actually have the connection and be able to grab the real server certificate. All right, so now let's talk about chains. So what we talked about before was kind of a simplistic way is that the server or the client encrypts a piece of data, the symmetric key, and sends it up to the server, and the server is the only one that can read that, and then they use that piece of information to change it. The problem is, how do I know I'm really talking to the server? How do I know I'm talking to Google.com? How do I know I'm talking to the push notification server? And that's what certificate chains have. So your server certificate it gets issued by a certificate authority. It's like VeriSign or Komodo or let's start SSL, which is the one I use because it's inexpensive, and by inexpensive I mean free. Or you can issue your own, but the problem with that is it won't be in your trusted root, which we'll talk about in a little bit. So if it's not part of this world government, these devices won't actually be able to trust it. The certificate chain is important because you don't have to have a direct relationship. So when I connect up to apple.com over HTTPS, my browser may not have never known about, that's a bad example because Safari is actually made by Apple. Let's say I'm connecting up to twocanoes.com and I want to secure transaction because I want to buy 1,000 copies of WinClone, which I totally recommend you guys do. So connect up to twocanoes.com, it needs to be able to trust that. And what it does is because my server certificate has been issued by something in your root store, by Komodo or by VeriSign, something that's part of that root store, it can be able to be trusted. And so since you say, I trust that issuing authority, you can then trust that twocanoes is actually the server you're talking to. Right? And one of the cool things, and that screenshot is actually from Keychain Access. And on OS 10, there's a little-known utility called Certificate Assistant that allows you to do a lot of cool things. If you're a developer or you're an MDM provider, I still think you have to do this. You have to create a request. So it's more common now so you do a request a certificate from a certificate authority. That's how you generate your push notification requests. But one of the nice things is evaluate a certificate. So it has a GUI way to go ahead and actually see if these things are valid. So you can do SSL, and you can put in any host name. So you put in google.com and ask host for certificates. That didn't work. Let's go ahead and actually put it on the SSL port. All right. That used to work. Google, there's Ed in the back. Google.com no longer has port 443. I can't believe that. It must redirect. I'm sure it's fine. Nobody freak out. It's still secure. Versus Apple always redirects and you do it, but they actually have it set up correctly. So this is a great way. It downloads the certificates from that connection, and it'll actually verify them. You can see that it says this certificate is valid, and you can say include certificates from my keychain, and you can show them, and we'll talk about make leaf in a little bit. But the big thing is this gives you a GUI tool. You can connect up on any port and evaluate the chain that's coming down from the server. So it's a great way to do it. So it's very similar to the Ask Client one, but allows kind of a GUI tool. If you do use this one, don't try to do it more than once per session because it gets confused. Make sure you do one server, you quit it, you start over again because it'll use remnants from the past session, which will make you pull your hair out. Yes. Which I thought I was insane until somebody actually told me that was true. So it's very common to not be issued a certificate by the certificate authority because they like to secure the certificate authority because if those keys get lost, their whole business is gone. Well, that's not true. That actually happened and they survived. But it's really, really bad for a certificate authority to lose their keys or to leak them out. So most likely you set up a certificate authority and you have it issue intermediate, and you split those out and have those issue those out. It also helps to distribute the system out. So most likely you'll get issued a certificate from intermediate authority. And that's great, except you have to most likely have an intermediate certificate installed or it has to be sent down with the chain. Because you have to test. You can only verify your certificate with who issued it. So I can't verify my, well, here's Apple. Here's one that here's my developer certificate. I can't go to the root authority and ask, is this valid? Because it won't even know. Because it never issued it. I have to go to the intermediate, and from there, I can validate the intermediate against the root. So you have to follow the chain up to the world government, which is blessed inside the system root. What was I going to say? Oh, so how do you get these intermediate certificates? The most common way is the server just gives them to you. It's like a gift from the server. So they'll give you the whole chain down. So they'll give you the server certificate, they'll give you intermediate, and they'll give you the root. And you think, why would they give me the root? I can't trust that. Well, it helps to know the path that goes up. So then you can easily find the one that you're going to check against in your keychain or in the root store or something like that. So it gives the developer that kind of piece of information. The intermediate helps you verify that that chain is actually valid. But one of the things it can do is inside the certificate, it'll tell you who issued it. And there's a CA issuers attribute that allows you to look and see who issued it, and they'll put a URL in there. And so Safari, mobile Safari, will actually look up your intermediate certificate and pull it down from the server if it doesn't include it in the chain. That's one of the things that for me was confusing because I was looking at this chain, it didn't actually have the intermediate, but it was working. And it's because Safari was doing this side connection off. And the funny thing about that is if you're in a network that blocks that, it was working fine for me, but for somebody else on a different network, it was failing. And the solution to that was just have the server give the whole chain down, and then we were fine. Safari was being too smart. It was going off and trying to discover it itself, which is a very cool feature, but it's not used in all browsers to be able to do it. But just be able to realize that this intermediate discovery can happen it can happen in various different ways. So it can be hard-coded. By hard-coded, I mean you just load the intermediate certificate onto your into your keychain, and that's a great brute force way to work. But then you have to install these certificates on your clients, and then there's the CA issuers and the server provided. So let's talk about the root store. So because this uses cryptography to verify the server certificate against the intermediate against the root, how do you know that's ultimately what's trusted? Right? Is this actually a trusted? If you know that the person that's giving you this information actually has the private keys, but how do you know that person is actually who they say they are? Right? It's because you can go and verify them up to their root, and you have a bunch of certificates, a bunch of roots that are trusted implicitly by the system. And that's all the certificates that are in the root store. So if you go into the keychain, you have a big list of certificate authorities that are trusted for anyone that connects up. If you go in iOS, there's a root store that you can't directly get access to, but it's kind of there. And Apple publishes right here in this KBase which certificate authorities are in the root store, which is pretty much the list. Before they had that, people at Apple would just recommend going to OS 10 because that root store is very similar. But you can see here, this is all the certificates that are trusted. You can get in some really interesting permutations of just trusting what's in your root store. And so Apple got into this interesting situation a couple years back where there was a problem with people are stealing in-app purchases because it was verifying that the SSL connection was a valid one, that it was by a valid SSL certificate, wasn't checking the issuer, was actually Apple. So what I could do is I could get one of the other certificate authorities to issue one that's a DNS name that I could connect up to. It would say it's a valid certificate, and that was good enough for that. And then people would steal level, whatever, from a game or something like that. That was patched, and now it looks at what the issuer is. But the idea is that there is places that want to remove stuff from the root store because they don't want to trust everybody. They just want to trust a few, the ones they want to deem, not what Apple deems as being the trusted ones. So be aware that just because it's trusted doesn't mean it might be trusted against the person you think it's trusted against. It just means it's trusted against one of your certificates in the root store. And Apple has their own. This is another awesome site. Apple has their certificate authority site. Turn the cranker. Go faster. Man, the Ethernet is so bad here. Sorry. Well, Ethernet joke there. So Apple publishes in order to be a certificate authority, which Apple is a certificate authority, but also to be able to have a lot of these intermediates, they publish those as well. If you're a developer, you know that things break if you don't have the intermediate certificate installed. But there's a lot of other things, like with MDM. One of these, and I don't even know which one it is, it must be the application integration, is the actual one that when an MDM provider provides it, that's the intermediate certificate for that. And you can actually test against that to see if it's an iPhone device, right? Which is a nice way to do it. So you can see who the issuer was. And this is a really recent addition. I haven't actually downloaded and looked at it yet, but that was kind of being able to verify what the intermediate was. It was issued by Apple. So the iPhone, when the iPhone is provisioned, originally it'll have this signature. What's that? Activating. That's right. When you do the initial ones, like they activate it in store or whatever, or you do it yourself, and it used to have to plug into iTunes to do it. But it actually installs an identity on the device, which is used to uniquely do it, and it's issued by an intermediate authority. And so Apple publishes the root authority, but they hadn't published intermediate. And this is the intermediate here, so you had no way to check if you were like an MDM provider to find out that was actually an iPhone device because you didn't have the intermediate to check it against. Not that it helps much, just an interesting factoid, right?
By the fact that if you verify that intermediate, by the fact that that is now publicly available, you can tell that it's that type of device.
That's correct. Unless Apple uses that intermediate to sign other things, but I don't believe that's true.
They limited it to a classic, yes.
I believe so. You can infer that, which is a lot what you're left to a lot of times with. So that site is a great place to kind of see what Apple has for their certificates. One of the things on OS 10 is you can actually go into keychain access and specify an intermediate as being the place where it stops checking, right? So you can say an intermediate or a leaf. If that's valid, don't check any further. In iOS, you have to have the root certificate installed. So just because you have the intermediate certificate and you don't have the root certificate because of whatever reason, and there's some weird chains out there where they have multiple issuing authorities where you're like, I don't want to do that, I just want to trust an intermediate. You can't do that in iOS. So you have to have the correct root, the correct issuer in order for it to work on iOS, which is normally always the case, but just installing intermediate you might think is good enough, but it's not. All right, so I put this in here just because the amount of services that use SSL, I can't go into the individual services to configure them, and fortunately, it's just a white blanket that if it's not using SSL, it soon will be, because that's really, if the direction is going to more of these mobile devices where you're not entering your password all the time, you're really going towards some kind of PKI certificate-based environment, and so you're going towards these kind of services. All right. So for troubleshooting, let's talk about troubleshooting this. There's 3 simple rules to troubleshooting this is packet trace, packet trace, packet trace, right? If you don't know how to do a packet trace, you need to learn a little bit about doing a packet trace. And when I first started doing packet traces, I thought, I'm going to look at the individual bits on the wire. It's like, how am I going to be able to do that? It's way too much of a task to be able, for one person like myself, to be able to do. But things like Wireshark, it'll actually decode the packets and tell you a lot of information about it. So you're not really packet dumping, right? You're just reading information about what's going on the wire. So just a little bit of information. In fact, I can troubleshoot SSL issues. The SSL server will give down a code which Wireshark will translate and say, hostname not valid. It'll actually tell you. And so you look like a rock star. You look at it and you're like, oh, the hostname's not valid. To somebody, it looks like you're looking at the Matrix, all the numbers going down. And you're like, oh, yeah, it's just that. And you're just reading what it says in the top, but it just looks to them because there's so much information. So Wireshark or any packet tracing utility will decode those error codes for you. And there's a couple other tricks that I'll show you, which is kind of neat. But there's some a little bit snarky, but the packet trace is a good thing. There's other things to do. There's some tools that I'll show you. I showed you one already, the certificate assistant, OpenSSL S client, and I have a product called SSL Detective that came out of this not knowing what iOS was viewing as being trusted or not, that I'll show you in a second. And there's also logging. And this is really hard to get to. On iOS, it's hard because people don't know. It's put in a weird place, and Xcode's probably the easiest way to get to it. I haven't done it recently. The IPCU will do that as well. But if you're talking to somebody that doesn't have that on their machine, you can't look like straight on the device. There's some apps you can install, but it's not the easiest thing to get the logging off the device, but it's worth the effort to get that. You can say, you know what's going to take me an hour to walk this person through to get logging? Is it worth it? Almost always is yes, because logging will tell you a lot of information. And so to get that logging working for that service, and that's the other really key piece, is that the SSL errors might not be in the system log, but in the application. It will be in the system log, but it'll be application specific that might be having the problem. So you don't know. It depends on what the application is. They'll give you varying degrees of errors. So it can be helpful. It might not be helpful, but you're kind of blind if you don't have that. So the packet trace is the first one. You know you can get that. And this is, for me, I had an easier time getting people to plug into the switch and do a packet trace than to get the certificate chain. Right? The certificate chain, for some reason, was like, it's not like they didn't want to give it to me, but it was hard to get for them because they had pieces of it, and they had so many different ones. They think this is the one. Right? And troubleshooting is just a nightmare. So plugging into their switch, their network guy is like, oh yeah, I can just turn that on to whatever mode is the promiscuous mode and capture all the packets. That was easier than getting the chain. And it was actually, for me, it was like the canonical, like this is what's happening, instead of this might be the chain. And the other thing to realize is that even though the chain is valid, it doesn't mean that the device thinks it's valid. And if the device doesn't think it's valid, it's not valid. So if you take that certificate chain and you put it on OS 10 or you put it on Windows, and it works great, and I had that before, it's like, we use that same certificate chain on Windows, everything works great. Why doesn't the iPad work? Why doesn't the iPhone work? And the answer to that one was it actually wasn't the certificate chain the device was giving out. So it doesn't matter if it works on a different device, even the same chain. If it doesn't work on that device, it doesn't matter. You're still going to get these errors. So you need to actually get the specific stuff about that device. So we already talked about certificate assistant. I always get it through keychain access because it's under the keychain access menu, but you can also go into system library someplace, I forget now, that isn't actually in there, but you can get it through the keychain very easily. And so iOS certificate validation. So one of the things that came out of this was all of this time I was spent trying to figure out if these chains are valid on iOS. And the problem with iOS is that you don't have access to the root store to look at it directly like you have on OS 10. You can say, oh, these are the roots. So it actually is in there. You just look at the KBase and you kind of know that's what Apple says. And that's for iOS 5 and 6, maybe a 4, but you infer a bunch of stuff, which is no fun. And the other thing is that you can look at what the server's giving you, but does the intermediate actually, is it resolving correctly? Is it being trusted by the root on iOS devices? So basically all I did was create an app that connects up to an SSL port, downloads the chain, and then asks the API, is this certificate, do you think it's valid? Do you think this is valid? Do you think it's valid? Then I give the entire chain and say, is it valid? And so I mark it as red up here if the entire chain is not trusted, and I mark individual ones if the individual ones aren't trusted. Doesn't mean they're not real, they're not good certificates. It is, what does iOS think? Because if iOS thinks it's not trusted, it doesn't matter. You're dead in the water at that point. So let's try a couple of these. And it's a free tool, so I'm not pimping that one. Though I do think you still buy 1,000 copies of WinClone. So anybody have a favorite SSL port they want me to try? I have a couple, but we'll make this real so there's no man behind the mirrors. Sentry? Oh, Sentry. Like that? Dot. Okay. 4.3? Congratulations, Mike. You have a well-formed certificate chain. A couple of other things that's neat on this. So this pulls down, this shows you what's on, that's pulled from the server. And so if he was missing an intermediate, it wouldn't go and pull off the intermediate. It's actually showing exactly what's pulled from the server. And you can actually drill down into these things. So you can see that it'll give you all the different information about the certificate. More than you would if you just clicked on a certificate that iOS gives you, because it only gives you a subset of the information. So it'll even show ones that aren't there, which is, I don't know. I'm just proud of that. That's why I want to share it with you, I guess. And the other thing, it has email certificates. So you open this up, it'll actually email. You can email yourself the certificate chain. So if you want to go and send it to your network guy who claims that this is the chain and it's not really the chain, you can email this to you, and then you can have an argument.
Does it work with desktop?
It does, works on any port. The only thing it doesn't work is if you have a start TLS. So it's got to be SSL running port on a port. What's a port? You want to try? You want to try?
Sure. Mail.techvolutionary.
Mail dot T-I-O, what? P-L-U-T-I-O-N. T-I-O-N. A-R-Y.com. Import. .org?
No.
Hey, bravo. Nice chain. Beautiful chain. And so, again, you can see this.
Chain's fine.
What's that?
Let it change fine.
So this is a great tool to be able to see what iOS thinks it is. You can get the chain from the packet trace, but until you actually say the device is trusting it. And I had I had very little support requests on this, but somebody wrote me, they had a problem with their MDM. Their intermediate wasn't being trusted. But the chain was, and the root was, and the server one was. And I'm like, it doesn't make any sense. But that tells us what the problem is, right? If you check the, I don't know if that tells us the problem. It's telling you that iOS is doing something a little bit weird associated with it. So this allows you to tell you what it thinks. So my guess is there was a problem with that intermediate. But at that point, he spent 99 cents. I wasn't going to spend a lot of time with him, but. All right, so that's SSL Detective, available on the App Store. For free. Well, I added ads and made it 99 cents, but, man's got to make a little bit of money. So the handshake that goes through, again, I don't want to go deep into this, but this is what you will see in the packet traces that we're looking at in a second. You'll see the server, you'll see the client initially connect up to the server, because you're the one initiating the connection. That's called the client hello. The server responds and the server says hello, and it sends its certificate down, or a certificate chain, or part of the certificate chain, or just garbage, right? You don't know. It's going to send some certificate stuff to you. It's configured on the server to just send what it has in this certain file to you. It's not like like you're setting up Apache. It doesn't take its actual certificate. It can just provide you what you have it configured for. So the reason I point that out is if the server can work fine on one device but not another, it's because it could be providing kind of lies to the client. And then it does the key exchange, and then it does all that. The big part we want to look at is the certificate piece. So we can eavesdrop. This is where you look at, and it's looking like a matrix to people, but you can look at, because they're looking down here, right? Like, how does Tim read this OA22B8? He's amazing. And I'm looking up here where it says, the third line says, bad host name. And so you can see that the info, it does decode all of this stuff. So all I'm doing is I've connected up to a web server, I don't remember what to, probably twocanoes.com, and I put in SSL, so it's just showing the traffic, and you can see that that's the exchange. So let me actually show that. We will go to a website. I just installed X11 like moments ago. Honest, I did. See, it's right here, Xport. I do? I did I tried them. I'm not going to argue with you. Because you most likely are right. Oh, I got to browse for it. See, that's what I did. Okay. Once again, Mike's right. Deny. Why?
What's I just
Always allow. There we go. Hey. All else fails. So just lose it. I knew I had X11 installed. I just didn't know why I wasn't finding it. That's what it was. Okay. What is iDisk? No, if you keep pressing the button, the elevator comes faster. All right. There it goes. Excellent. Hey, look at that. Tim can run an application. Yay! And the wired is EN1, right? I hope. Oh, God. Maybe it's not. EN0? Really? I thought EN1. Okay, I'm going to go there. And where should we go? Anybody have an interesting SSL-enabled web server?
GitHub.com.
What's it?
GitHub.
AFP5, where did they go? Oh, sorry. Oh, it went there. Redirected. Okay, sorry. Yeah, great. I don't even know what port I'm on. Okay. I have no address. EN7 for the win. That's awesome. How is that even possible? All right. There we go. Okay, so let's clear this. One of the things Safari does is that I refreshed it, and so it didn't ask to change for the second time, so you got to quit Safari and start it over again in order for it to actually ask to download the chain. And there we go. And there's server hello. Here we go. Certificate, server hello, done. So in here, so you can see this one. It would give you an error message in here if it's something that it can detect an error code. And maybe if you have, not the certificate expired, if the client is refusing it, that's one thing. That'd be in the logs. But if this is something like the actual negotiation, it's using the private key, public key's wrong, something like that, it'll come up and show you the error message here. But the one thing I love about this is I discovered after many hours of not believing what the person was telling me on the telephone, I looked at the packet trace. You can actually see here are the certificates that are sent down. And you can see that it's sent down github.com and then the DigiCert authority. And so this is the actual certificate. And you can go in here, signed, let me see, where is it? Yeah, right here. So if you do file, export as selected packet bytes, and save it to your desktop, because there's no better place, and call it GitHub. And now we're not, it's going to be binary, so we have to do DER. And now hopefully, I go here, there's you can get the GitHub certificate, right? So you know that's the real certificate chain that's being sent from the server. And yes, I had let a little blood from this, so it's a sensitive area, but I think it's helpful because people don't realize the stuff that's being sent down from their server, and I was lied to on the phone. Yes, that's the chain you were going to get, and no, it wasn't. So, but I've forgiven him. Really, I have. All right, any questions on that so far? Can I do another one? It just excites me to see that you can do this. I'll do the other one. We'll do the root. File, export, selected packet bytes. Call this root. Oh, no, that's probably bad. DigiCert.der. There it is. There's the root certificate. So that's kind of cool. You can pull it off the packet tray. Another advanced, awesome, blew my mind Wireshark trick was if you go into Preferences, which I forgot, Edit, Preferences. And this 1040 by 480 is just great. Protocols, TLS, SSL. There. SSL. So, the person that oh gosh, the screen resolution, there we go. God, I just wish that Aqua would go away and we all could be in X11 all the time. So the server has the private keys. So decrypting traffic to the server is hard to do, but if you own the server, you have access to the private keys, right? I'm setting up an Apache server or Nginx or whatever. I go and I get issued a certificate. I have the private key. I have the public key. I own the kingdom for my kingdom of one, I guess, the king of one. And I want to decrypt that packet, that packet trace. I can actually import them here, and then all that encrypted traffic I can now see. So when you have a service, it's like you set up OS X server, and it's encrypting all the traffic over the wire, and you want to find out what the protocol is. Right? You can say, maybe it's written in Ruby, so I actually look at the source code. Oh, that didn't work. It's binary. You can go in, take your SSL keys that are in your keychain, put it in here, and actually look at the commands that go on that web service to something else. So it's a great way to decode protocols. So that's so great in troubleshooting because you don't really care of what the actual traffic is. It's how it's encrypted. But it's a great way for Wireshark to be able to actually decrypt the packets. When I first did this, I'm like, whoa, that's awesome. I can actually see what this traffic is that's going back and forth. Does what? Charles Proxy? I don't know. Oh, okay. Charles Proxy? So I can't recommend this because I didn't actually mention it. So you guys need to come to Alistair's session that's next, and you'll learn all about Charles Proxy. But me, I just stick with Wireshark. But no, that's cool. I'll check that out. I have no idea where Keynote is. There we go. So you can see, you don't really need, all you need to do is turn this on, figure out what port you're running on, right, what Ethernet port is, and then look at these, sort by SSL, and then look, I don't go high enough. Just look at the first couple lines. It'll tell you how far it got in the progress, right? Because if it just gets to the client hello, you know there's no SSL running on it. If it does the server hello, and it's not sending the certificates, you know that's going to be a bad thing for the client. So you really just need to look at the info section on the right-hand side. And that'll give a long way to do it. Another piece that can do this, I don't know how much, I guess this is really, the only reason I would actually use this is if you want to cut and paste sections of the certificate into an email, it's hard to do that in Keychain. You have to do screenshots, and I find it's really, like when somebody sends me a screenshot of a terminal, exactly like this, I'm like, really? You're going to send me a screenshot of the terminal? Can't you just paste the text in? This ASN1 parse allows you to take a certificate, it breaks it down into the individual components, right? So you can copy and paste it and do geeky things with it if you wanted to. You could actually probably use it for scripts and things like that. But it's another piece of OpenSSL that allows you to take the certificate and breaks it down into the different attributes. All right, so now I have a challenge for you. Everybody open up your laptops. 14 minutes.
Does that have internet?
Yeah, on this wireless network. That's why it's a challenge. And it's called, What's the Problem with These Servers? What's that?
The first one's French.
This actually might not still be broken because it was tweeted from a friend of mine last night as a problem, not just randomly, like he's having a problem with his SFTP server. I checked it this morning, and it was working, and I figured I'd offer it up. First one doesn't connect. Okay, well, let's try. The White House one is awesome. Oh, here, let me go there. No.
You have a really good
There's two things with that. Hold on, let's start with the first one. Oh, that one didn't actually work? Oh, no. It doesn't work? I checked it before I put it on the slides. All right, there's a great example of SSL not running. No, so that one failed for no reason. All right, we'll move on to the next one. So the whitehouse.gov one is hilarious. And it's, to be fair, right, when you go to, you almost never see a reference to whitehouse.gov on HTTPS. So they don't really offer it over HTTPS. But if you force it, right, you will get an error. Oh, no, the redirect. Oh, this wireless is great. Oh, yeah, this internet is great. Okay. Can somebody actually get to this? Oh. Wait a minute, I'm still on Wi-Fi? Hold on a second. Oh, the wire does that also. Oh, that's probably why SSL didn't work. Oh, God.
The whitehouse.gov one is fine, but www is
No, both of them are broken. Yeah, see, if you go to whitehouse.gov, it redirects to www. And if we go to HTTPS, it gives certificate error. Oh, that one actually redirects. So if we force it. So you can see there's two separate problems. So let's look at the first one. And we'll use keychain access to do it, because that's a good GUI way to go about it. And SSL, whitehouse.gov. Oh my God. Oh, sorry, this did the same thing twice. You have to put a port. Honest, I checked my demos before I did it. They blocked me. The Secret Service saw that I was doing all these tests, and they... Okay, I should grab a screenshot of this. What's that? Let me try www. This was the highlight of my presentation. This sucks. All right, I will give it. No, I'm not going to get on my Wi-Fi network hotspot. Okay. Wireshark. Oh, Lord in heaven. Okay. Whitehouse.gov 443. Wait, why is that working in keychain access? Oh, actually, let me do it. Let me do it through Safari. Okay. Because this actually will be good enough to see. Good. Okay. There. So that's www.whitehouse.gov. What's the problem with this? What host name is it checking against? It's checking against Akamai, right? So there's no host name in this certificate. So if we look, no, there is an intermediate. That is the intermediate. There's no server certificate. And there's no and the intermediate doesn't have a host name associated with it because you wouldn't be serving a host name. I don't know how we put up for the White House for this because there's actually other services that it uses and it doesn't expect traffic on this. But it's just this is a misconfiguration that people happen when they are serving services on this. This one I don't know if it's not actually serving it's just redirecting on that port. And if you go to whitehouse.gov, it's different. Oh, I should have kept them up. Okay, see how this one's different? I'll get them both up here. Is this the other one? Okay. Okay, I think we got it. Okay. So now this, it's like they're mirror images of each other. This one fails because it says a host name's not valid, right? But it's a wildcard. And whitehouse.gov, if it's like halfway in the redirect. What I actually went to was whitehouse.gov. So it's trying to check whitehouse.gov against star.whitehouse.gov. And whitehouse.gov does not match star.whitehouse.gov. So when I first did this, I thought, I can get it to match because it's expecting www.whitehouse.gov, right? You go to www.whitehouse.gov, it goes to a different server. Are they the same certificate authorities? Completely different certificate authorities, probably different servers, and it doesn't have a server certificate associated with it, right?
I came out of the meeting saying, I don't care, get it done.
But for me, this is like, from the root, if someone had asked me, does whitehouse.gov match star.whitehouse.gov, I probably would have said yes, right? Until I did it and I scratched my head, it's like, oh, that makes sense, that star is on the other side of the dot. And then this one not actually having the server certificate, I'm not sure why that is, but. All right, and now that we have the internets back,
That's good.
let me try my French one again. Is it?
Certificates don't be better. Be more secure.
All right. Can it not? Is it out of DNS? Is it not? Oh, it doesn't even resolve it. Is it possible that Penn State blocks all French addresses? No. That's not. They're called freedom fries. All right. So references. SSL Detective is on the App Store. Actually, I can add in Alistair. What was the thing called? Yeah, Charles Proxy is a good one. I'll make sure this is put up. Charles Proxy. And since you guys aren't familiar with Google, I'll go ahead and Google it for you. Charles Proxy. Oh, it's actually charlesproxy.com. That's .com. Look at that. And the internets, right? Because I did not cover anywhere near the whole PKI certificates things. If you want to get more involved in cryptography, individual services, I couldn't put up all the references. But the big thing is these tools, as well as the built-in stuff in OS 10. So, all right. Question and answers. 6 minutes. Yep.
Can I ask a silly question? And it's not really all that silly, it's just kind of good. Back in IT, we talked all about S-line certificates and using those in laptop and iOS devices. Sign up for an S-line certificate, work straight on the laptop, put it out to the devices, and all of a sudden, iOS devices think it's great. Android devices, obviously ones I control, manage or touch, see an untrusted certificate out of it. Is that likely an intermediate that's missing? Is that likely a root that's not trusted? Do you have any experience dealing with those kind of environments?
So I'm going to need to get a packet trace, a log, the actual environment that you're in. So yeah, it needs all those pieces to be able to trust it. And that does sound like, I don't know if Android has Apple's root certificate trusted. Oh, that web page, the certificate authority is where you submit to be have your root certificate trusted by Apple's devices. So it might be that you just hand it off to Ed, and Ed will go ahead and get it trusted in the Google. What's that? No, he's saying the other way around. Android's not testing the Apple one, but you'd have to.
It's not Apple. Apple's not certifying that.
No, I'm sorry. I guess that's true. What I'm saying is that the root authority that was trusted by yours. So. Yeah, I guess you're right. It wouldn't be issued by Apple, but it would be whatever root you had is not in that one. I'd find out from other Android users if anybody from that same certificate authority has the same problems. Yeah.
A little bit off topic, but would anyone count me away from wildcards? It's pretty tempting to wildcards or anything rather than.
I think used to be the case a couple of years ago, but these days I think wildcard's pretty prevalent. Anybody have any different experiences with it?
We choose not to do it, but it's just an institutional way.
Right, and they're expensive. And there used to be issues with browsers not recognizing wildcards, but that's pretty much gone away.
So I think that I like this slide with your site's on SSL now. Wait.
Yeah.
How much communication on the internet is going to be SSL protected, how many different hosts do you want to make sure are validly identified so that you can trust them over a non-trusted medium like the internet.
Yep, there's I just installed analytics, and I used to get a lot of information now. It says secure search because Google has switched over to SSL and they don't share as much information to the refers because they want to kind of protect that, and so that's going to become more common. It's going to be a lot harder. The information leakage is going to become a lot less with SSL, or non-existent, hopefully. Yep.
Just a quick commentary on, in terms of being able to trust the service to be secure. Oh, it's an SSL and searching isn't necessarily 100% confidence that you can have because it's really bad designed application on that server. It can have that SSL chain all set up fine, and then you like do other stuff in the clear in such a way that you're probably not going to wonder about it. So like when FireSheet that I mentioned earlier,
Right.
was a new thing. And basically it's like, oh, we'll do HTTPS. It still worked because they were still doing your session ID in the clear. And so
okay.
Grab that, and certain bank websites, actually I should choose one of them, were also vulnerable.
Great. All right. Thanks. There's my example. I knew I should have chose US first. I don't know.
I think it's really instructive because it's like, oh, I know all these analytics, right? And I know this is a secure session, and well, now some guy's screwed up, and that part's secure.
Right. Well, if your password was 1234 at the bank too, it doesn't matter how secure the session is. But it's a good point. A very good point.
The
Yeah,
latest version of Safari, I can't speak to previous versions, but the current one in outline show that like 604 is very strict about whether or not they'll show you the lock or not. If you go to a page that's SSL, but let's say it pulls the resource and it's not SSL, like you're pulling a font from Google CDN or something like that, it will not show you the lock because it knows that there's a resource on that page that is not even retrieved or SSL.
Oh, okay, good point. I didn't know that. I know that prior versions would warn you that there's mixed insecure and secured ones. I think that's probably the way they get around that is they just consider it insecure if you mix any of that stuff. And that gets in trouble, I know, personally from the analytics, if you're not using, your analytics stuff is going to a non-secure port, it'll consider your stuff not secure, which is a good point. All right. Thanks, everybody. We're out of time.